Good morning, everyone. I'm Martin from Aquatic Control Engineering. Thank you very much for spending the next hour or so with James and I, who will be taking you through the fish migration solutions we have to offer at ACE. Our vision as a company has always been to protect people, property and biodiversity. We believe in the fact that we require flood defences to protect property, protect agriculture and assets such as that, which we all rely upon. However, these flood defences, they should not hinder or stop or prevent in any way any kind of fish migration. Which is why we've been putting forward a portfolio of products which aid both sides. So it's very much a portfolio to allow fish migration to pass through whilst maintaining vital flood defences. So why do we need flood defences? Well, climate change. We all know that climate change is happening. The weather's getting more extreme, so not necessarily that we're getting more rainfall per annum, but it's kind of happening all at once. There's more forest fires. We've seen it up in the moors as well, of course. We've seen hurricanes, and generally the weather is getting more extreme. It's not just in the UK, but it's all over the world. We can see here that every single continent is experiencing more regular flooding on a more regular basis. This, of course, leads agencies across the world, and that's not just the Environment Agency, but in every country to increase and bolster their flood defences. It leads to the creation of assets such as these. You've got some large non-return valves, as you can see in the top left, land drainage pumping stations, as you can see in the top right. You've also got assets such as the bottom right, which is at Morpeth, which is essentially a flow throttling device. So the way that particular project works is the River Wansbeck can take 100 cumecs through the centre of Morpeth, which is just north of Newcastle. And as soon as more than 100 cubic meters of water is coming downstream, they start to close the sluice gates in order to pen that water and build a temporary storage reservoir for it so that the town of Morpeth is protected. Of course, we all know about weirs. There's historic weirs, there's weirs which are for production of food and textiles in the past, where of course we were harnessing the energy. And a lot of them are still present and ever prevailing. So they're huge barriers to fish, all these kind of objects, but we'll explore a little bit further how we can categorize them into different kinds of groups. On the left-hand side, you'll see blockages. So they are causing damage to fish migration in a more passive way. They won't actively destroy or harm a fish. However, indirectly, as the fish is not able to continue with its normal life cycle because it's not able to migrate, and this counts for freshwater species as well as the species that everyone thinks of as being migratory between saltwater and freshwater. But freshwater species also need to migrate within different areas, different parts of the river system to carry out their natural life cycle. And non-return valves, items such as tilting weirs, any kind of barrier that we put in on the watercourse can, of course, hinder the fish passage. We've also got mechanical items. So this tends to be rotating equipment that's been installed in rivers, and that can be hydro turbines as well as land drainage pumping stations. But generally it involves rotating mechanical equipment, and that will cause generally direct damage to fish from obviously the mechanics of the item striking the fish and causing fish damage. ACE originally started working on fish migration solutions back in 2004. In 2004, we were approached by the Environment Agency in particular to look at or explore how we could provide a non-return valve so a flap valve that allowed or aided fish migration. I'll be honest with you, back in 2004, we didn't really know about the impacts on fish. ACE was very much a flood defense company. However, it looked like an interesting challenge. We're a company that stands for innovation, so we love to try and come up with new solutions. And what we did is work hand in hand with the Environment Agency and developed originally what we call the PET flap. It's named the PET because it's kind of like a cat flap, but upside down, which you can see on the right-hand side. The way this works is as your downstream level starts to rise, it picks up this floating ballcock, lifts it, which eventually pulls the door upside down and shut. It's very simple, straightforward, and it works quite effectively. Up in Cumbria, for example, the various rivers trusts have done some monitoring and found glass eels passing through. There is a weakness to this particular design, and that's in terms of tidal action, particularly wave action, can obviously cause the door to move a lot. So we actually moved away from that kind of design in any kind of tidal sphere. And that's where we created the reset system. The reset flap is a top-hung fish-friendly door. It's raised as soon as the float comes in, but I've got a nice little animated video that I'm going to show you next to explain it. It is a little bit tricky. And then, of course, we've got the side-hung doors. Now, these are much beloved to North Wales. They seem to have quite a few assets where they're using our HDPE doors, but we do also have some dotted around the rest of the UK, a couple on the south coast, for example, and this one is in London. This is actually the entrance to a Larinier fish pass. The nice thing about the side-hung doors is they open nice and wide, allowing the maximum width of your culvert for fish to be able to migrate upstream. They also have a very low opening pressure, therefore they open when only a trickle of water is coming through, which all the fish species, or a lot of the fish species, can get through. In Fairborn, in North Wales, for example, they're finding elvers getting through these absolutely no problem, which is really, really great to see. So this is the animation to explain the reset system. So the way you've got to see the reset type of fish-friendly flap valve is it's a buoyancy tank, which has got a non-return device in the bottom, one of our wire stops, and an air vent or a hole in the top of it. So this pipe at the base, that has the wire stop, non-return valve, and at the top is the air. So if your upstream head is higher, operates as a normal flap valve, lets the water out. The downstream level comes up, it lifts that float, and therefore buys a window of time for your fish to get through. When the tide goes above the float, it fills the float with water, which causes it to drop shut. This is a particular project up north of Newcastle, near Berwick-upon-Tweed. You can see the float fills full of water, drops shut. You can see it's dropped shut because, of course, the wave action. And this is the wire stop non-return valve, which we use in the bottom, which holds the air in, but then lets the water out as soon as the tide drops below that particular valve. They've been proven to work extremely well. The Environment Agency in the Northwest have got some, this is Cocker Bridge, for example, some 3x3 meters, which are near Lancaster. Broadfleet, also in Lancaster. This one is Ross, which is up near Berwick-upon-Tweed. And there are various along the south coast as well. They seem to be performing very well, and they're much more robust in terms of seeing any kind of wave action. And in terms of monitoring, we've had great reports, particularly from the northeast, where rivers which had no salmonids whatsoever are now starting to see sea trout reds upstream of them, which is, really good. It's really positive. This is one of our side-hung door projects. As I say, North Wales have quite a few of these. This is Pont Robin. And yeah, you can see in this photo itself, it just shows how wide the doors can open. So as soon as there's any kind of head difference or the tide is running out, the water can flush through, open the doors nice and wide, and therefore you're getting the fish to be able to swim upstream through the culvert quite easily. It's got some other incredible benefits. One of the big ones is very little debris can get caught. So one of the issues with top hung flat valves is, of course, you require the weight of the water to push the valve open. However, if you get debris coming downstream, it can sometimes get caught behind the valve, and it quite often requires somebody to go down there in terms of maintenance to lift the valve up, pull it out. I must say with HDP, there's less of a risk than cast iron because it is lighter, but the risk is still there. With a side hung door, it opens so wide that, yeah, the debris can just float quite easily through the door. These are some nice CCTV footages of Pont Robin, which they've been looking to make sure the doors close on time, that they're opening, that there's no debris. And what they've actually found here is typically they visit, in North Wales, they visit their assets once a week for a non-return valve, but they're so confident in this one that it's not going to get any problems with debris or anything, that they're only visiting it once a month. So that's a huge benefit in terms of the maintenance reduction, also from carbon footprint reduction, because of course you're not sending people out in vehicles to go and inspect the sites as frequently. So it's positive for fish, it's positive for maintenance, yeah, lower head loss, a great deal of wins there. So after we were working with the Environment Agency to solve the problems with the fish-friendly flat valves, the Environment Agency said, yeah, we've got a new problem for you to look at. And this was back in 2007. So in 2007, they said, well, we need to get elvers upstream. We need to, the eel is a species that is in major decline. Yeah, all of us are aware that more than 90% of the eels have been wiped out, and we need to do whatever we can to help them with their migration, to make sure that they don't become extinct ultimately. They're also an important part of the ecosystem. Of course, a lot of birds and other animals, yeah, they live off the elver, so it's part of a much bigger picture protecting the eel. So as a company, we said, yeah, no, we're definitely interested in looking at how we can solve that problem. And we worked really closely, hand in hand, with the Environment Agency, but in particular these two rivers trusts, the South Cumbria Rivers Trust and the Loons Rivers Trust, in the early days when we started to develop the eel pass. I'm going to be honest, yeah, the first eel pass wasn't necessarily the most successful one. However, we've learned such a great deal over the years that we're getting it down to a really fine art. I am conscious that I haven't had a look at any questions. James, may I ask if there's any questions that have come in at all?
Morning, everybody. We have had one question, but it was more a technical issue about getting connected, Martin. At the moment, there's no questions regarding the technicalities of it all.
Okay, no, that's great to know. I would like to let everyone know that you are more than welcome to ask questions. I'll stop periodically through the presentation and just ask James to read them out, and then either James or myself will be able to answer you. So please feel free to get involved, and yeah, definitely get asking some questions if you like. So yeah, back to the eel pass. You can see this particular one we did in aluminium. We powder coated it in green to make it look aesthetically more pleasing. It featured on the BBC's Country File in 2011, which was quite a nice moment for us. But on this one, as you learn with everything, you realise that metals and eel passes aren't necessarily a good idea. And that's because they live at the side of rivers and therefore are prone to vandalism, or particularly if you're using more expensive metals, which you have to in water, such as stainless steel and aluminium, they tend to grow legs and run away. Yeah, they get stolen, unfortunately. So we looked at what other materials could we use. And the obvious one for ACE is always HDPE. We're so used to working with the material, since it's what we founded the company was on in 1995 was HDPE and stainless steel flow control equipment. We said this must work for elvers. So we started to make HDPE eel passes. This is a particularly nice example from the UK's largest land drainage pumping station. It's the second largest in Europe, St. Germans. and we delivered the eel pass that goes up and around the outside of it. It was being monitored by the board, and during April 2014, over 50,000 elvers in that 1 month were monitored using the eel pass. Fantastic figures. We're really, really pleased with the results. I would like to also note for any of you who are thinking, well, that makes an absolutely fantastic bird feeder, that. Not great for the elvers. It does have lids. It just doesn't quite give the same effect if we had a photo with the lids on it. Parts of flood alleviation schemes, of course, all across the UK are putting in barriers, and these barriers also need fish passage solutions to them. This is part of the Leeds flood alleviation scheme. You can see the massive, it's a big inflatable weir that they installed here, and they installed that to be able to maintain the levels in the river to allow ship passage and boats to be able to pass. However, when it floods, these weirs can ultimately just collapse to make sure that the water can all get to sea as fast and efficient as possible to protect the city of Leeds. Of course, most of the time these barriers are up, and therefore fish and eel aren't going to get very far without some assistance. We work closely with the Environment Agency again, Leeds Council, and on this particular scheme, an array of contractors and consultants. And we work very closely together with everyone to design the fish and eel passes that we delivered on this project. This isn't the only eel pass. Those, I believe, in total 4 or 5. And then we also supplied all of the HDP, well, all of the fish passes with the HDPE Larinier tiles, as you can see in the photo on the right. The HDPE Larinier tile, it's a more environmentally friendly version of the traditional approach, which has always been stainless steel. At first, people were a little bit nervous. Is the material going to be strong enough? Is it going to work the way that we want it to? And we've been using it on, we must have nearly 100 fish passes with the HDP tiles now. And the feedback is absolutely fantastic. It saves a great deal of time to install because HDP is light. We can make a whole tile with 5 baffles on, which can quickly be anchored in, rather than installing individual baffles one by one, which makes it more efficient for an installation perspective, more cost effective. But also HDP has a much lower carbon footprint to stainless steel. So it's a lower carbon solution to stainless steel alternatives. Yeah, the material is not quite as strong for that initial impact, maybe, which is why at the top we have, you can see here, installed 2 rows of stainless steel baffles. So any logs or impact is taken by the stainless steel. But for the rest of the fish pass, where it's never going to see that abrupt force, it's absolutely wonderful material, and it works extremely well. We've done a great deal of eel passes all over the UK, and it's not only for the Environment Agency. The utilities companies are requiring this more and more. We're working closely with United Utilities at the moment. We're just finalising. This is one of a package of eel passes that we've been delivering. This one's at Garstang, up in the northwest. But we've also been working with Anglian Water, with Severn Trent, amongst other utility companies. So we can work together with the utilities companies. We do a lot of the design in-house, which is what James is going to show you in a minute. And how that helps by us working with all the partners and being able to put the design together is we create a design in 3D, which everyone can take a look at. The fisheries teams can look and approve. The utilities companies can say, I'm confident that this is an approved eel pass because the Environment Agency's had a look and they're happy. Because it's 3D, you can have consultation from locals. What's it going to look like? Are they going to get happy? And it means that we can produce a product which everyone is going to be very confident in before we've actually manufactured it, which means we can put it in one go, and crack on. We can also be very creative in the way we have to do installations. As you can see, this particular project, as well as this one, how high the eel pass has to go. Means that sometimes we have to use things like man riding baskets, we've used floating pontoons, but we have expertise in all of that. So trust us, even if you've got a really challenging place, we can put an eel pass in there. Here gives you a selection of a few other eel passes that we've got across the UK, but ultimately we've delivered nearly 400 eel passes across the UK, and are generally regarded as, you know, the company who worked with the Environment Agency, worked with the Rivers Trust, is still working with the Environment Agency, Rivers Trust, to make sure that the eel passes are as good as they possibly can be. I did want to quickly touch on monitoring options for eel passes. So we can do various things. This one was for Bristol Water, a collaborative project between Bristol Water and the EA, where we delivered a trapping box. So you can see here, the eel pass, actually it was 2 eel passes on the side of the river. They came up, one went over the bridge to join the other one, and that's why you've got 2 ramps that are approaching the box, as you can see here. The box has got some nets, so the water is being fed in, it trickles over the eel pass, the rest of the water stays in the net, and therefore the eels are gathered in there, and obviously routinely people go down, open the lids, have a look. But this particular one, you can see the footstool around the outside. It's been designed in such a way that young people, particularly schools for example, are often going down to site as part of their lessons and learning about the eels. They're able to handle them, put them back in the river, talk about them, and the Environment Agency do an incredibly good job educating the locals using this. So yeah, really nice options there. Of course, monitoring them by hand is very time consuming, and therefore we've also worked together with our partners VACI to create a ELVA counter. So the ELVA counter is based on existing smolt counting technology. The smolt counting technology is already used heavily in the fish farming industry, of course, for grading smolts and putting them in different tanks. So it's used to counting large volumes of very small fish. And that's why it's the absolute perfect option for counting the ELVAs. This is the first ELVA counter in the UK. We had a couple of little teething problems with it because, of course, it's got a white underbelly and therefore algae started to grow on it. So we had to make it more accessible so that cleaning is going to be working. But generally, I think there's a lot of promise in this. And can you imagine if you can automate all of this counting, you're going to get so much more data, which is going to be able to give you much better picture of what's happening in your catchment. With the counters as well, we're making them modular to suit any ACE eel pass. So you could theoretically, you can see there is some cabling and ducting and things, but you could set it up on one pass for say 2 or 3 years, remove it and then put it on a different eel pass further upstream as long as it's an ACE eel pass because it works with our flanges. I thought I'll hand over to James. He has some 3D models that he's going to show you, which will give you a better idea of the design
Just
aspect.
before you do that, Martin, I was going to suggest we've got a number of questions popped up. I wonder if we could just address some of the answers before I present my bits and bobs.
Yeah, that sounds like a good plan.
Yeah. Is that okay? Good morning, everybody, by the way. Right, let's just start with these first ones. So we've got, what is the mechanism for closing the side hung doors? Do you want to answer that, or do you want me to answer that one?
I'll let you answer that, James.
Okay, so basically, the side hung doors essentially are limited, so they can't open very far or too far, and essentially they rely on the water flow to help push them closed. They're a fairly traditional design, and you probably will be aware of side hung doors that are made of timber, which have been around for centuries. But basically, it does require just a small amount of flow in the backward direction, which is essentially shortly after the fish are going to be going through the side hung doors. Hopefully that answers that one. If anybody wants to ask any further, then by all means drop it on the chat there. On the tidal flaps, we've been asked, do we have an option for a dampener to allow the flap to stay open for any longer? Martin, you've probably got the most up-to-date information on that.
Yep. No, we've been looking at the dampeners. It is an option that we've got available. One thing I would say with the dampers is it's really important to understand it's not a one damper suits everything solution. Some of our competitors have made it sound like that. The reality is, of course, dependent on the water pressure, means that you need a different strength or resistance on the damper, because otherwise you can't be confident. If you put a damper in that's too stiff, then your valve may never shut. Vice versa, if you put in a damper that's too soft, then your valve will always shut too easily before any kind of fish passage has happened. So what we can do is work with you and with the levels, agree the point that the door shuts on, what the flow is going through the door the other way, and make sure that you get a damper that's actually shuts at that particular moment. That's a big differentiator between us and our competitors. Of course, that does cost a little bit more because there's some engineering that's involved, but it means that you get something that works rather than just a tick in the box. Is there any other questions that we've got, James?
Yeah, we've got one or two more. So basically, with the Leeds Eel Pass, it's saying how does an operative access this? I would suggest that we can just hang fire on that question if we can, because that'll probably come up in my little presentation with the design.
Yeah.
We've got another question that says, with more emphasis on plastics in the environment and the potential for bristle plastics in particular to deteriorate over time, what work is there looking at or solutions for using more natural products? I will have a little bit of an input. You can obviously add to this, Martin, if you wish. Basically, the materials we use do have a fairly long design life and material expectancy. I mean, basically, HDPE has a 50-year design life. And the bristles, from what I'm aware of, we use Burlon, it's called. And it is, again, it has a particularly long life. It's particularly robust in an HDPE base. So it doesn't actually pull out. Both of those plastics are also used in the food industry. So they're not going to give out things like microplastics and that sort of thing. We have looked into natural products, but what we do find is occasionally that they're not as robust when it comes to strength. Have you got any more to add to that, Martin, at all?
The only thing I'd add is particularly on the HDPE, because it's a question that I get asked a lot about our flap valves. HDPE, the HDPE we use is black, and it's black because it's impregnated with carbon, and that makes it UV stable. And when it's UV stable, it's very difficult for it to degrade under sunlight into microplastics. Of course, if you're going to put huge amounts of abrasive material through it, then parts will chip off or you'll get some microplastics come off it. But in general, in watercourses, it's not like you're shot blasting it with sand or anything which is going to cause the material to release particles. It's generally very clean water, or with a little bit of debris in it, but nothing that's going to cause the material to actually break up and fragment. So I think it's a much smaller concern for the kind of products that we have compared to the real contributing products such as road tires, those kind of things, materials which are generally used in an abrasive environment, which is where a lot of these microplastics come from.
Yeah. We've got another couple of quick questions. How many sites of the Vacchi Elva counter? Obviously, the one we showed there was East Mills. I'm more aware of the ones that Vacchi have done in other countries. Martin, have you got any other details?
This is the first one. We're quite open to that. We've, as I say, that's why we've got a couple of teething problems with that one that we're overcoming at the moment. Because I think, has it been done yet that it's been moved up, or is that in the process? Because
it's very shortly. Basically, there is an issue with the with one element of it. I think it's the pump. I think the pump needs to be replaced. But yeah, other than that, the work has been completed. Yeah. Yeah. We are getting one or two more questions, but I'm just a bit conscious of time. I'm thinking whether we move on a little bit, Martin, and then pick these up in a little while.
Yeah, no, I think that sounds like a good plan.
Okay, so what I'll do, I mean, I'll try and address these as well while I'm talking. So if you just bear with me, I'm going to move on. Right. Okay, so can you see that, Martin? I'll just ask yourself because obviously people can't answer me. Hopefully that is the 3D model of the new eel pass design you can see.
Yeah, we can see that.
That's great. Okay, so basically this is a new iteration of our eel pass. We've had a couple of test sites that we've started to use this on, but essentially we've taken on a lot of feedback from particularly the Environment Agency, but other clients as well, our own installation team, our own suppliers, various other people, to make it perform more effectively, make it more efficient for elvers and eels to use it. We're actually undergoing some development work and some research with the Environment Agency at the moment, where they're actually using it to do some trials, but also to try and make it a lot easier for us to fit, us to manufacture, etc. But a couple of the key features that we've included here are that the brush is now actually impregnated into the base of the channel. So one of the previous issues that we've had is that we had it on separate board that was secured to the channel, and there were issues with it either coming loose or with it becoming just bear with me, there we go, allowing eels and things to get trapped and this sort of thing. So we've impregnated that into the base of the channel to make it a lot more robust and a lot more user friendly for the eels. There was a question about maintenance, about how you access the pass for cleaning and that sort of thing. One major issue we've always had to try and overcome is actually securing this so that the lids stay closed, but also allow access without having to get access into the river a lot of the time. What we've done with this one is essentially we now have locking pins that also act as a lifting eye to allow you to lift it. So I'll just show you a little animation. What you can see there is you just give it a little bit of downward pressure and twist these eyes, and that allows you to open the lid from above. We also provide lifting poles that allow you to do that from the surface. The other major change to this is also the fact that we've got a V-shaped base, so that allows you to have different depths of water, different flow rates down the pass. And what some of the trials and some of the research is showing us is that different flow rates do have a big effect on the eels moving up and down the pass. So rather than having just a flat bottom, it does make it a lot more user friendly for the eels. We also have a number of other items. So the monitoring box that we use for the eel pass has always had a bit of attention that people want to see. There's quite a lot of new features to the new box that we have. So essentially what we have now is two lids that you can remove fairly quickly and easily. That gives you good access into the box. We also then have a splitter section which allows us to divert the water into different elements of the pass. So we have one that drops the attraction flow into the channel to allow water flow through the channel. The inlet is this section here, so that comes from the pump into this section of the box. It then essentially distributes the water throughout that tray. We also have a flushing flow that then drops down into the bottom of the box to help flush the eels out of the monitoring section. And we also have another flow which allows us to add a showerhead screen or a further attraction flow. Just to show you as well, if I just hide that, you can see that we've got a point of no return for the eels, so they drop down into the box, and then once they're in the box, they can't climb back out. They also get positively flushed into the exit pipe. We do also, if you wish, we do have the facility of adding a trapping section to this pipe here. So if you want to use it for monitoring, you want to use it for trapping, you can do that. And just very quickly, because I'm aware of the time, this is an example of one of the sites that we've recently done. Just to give you an idea of what level of design that we do. We take topographic surveys, or we take our own surveys. We create a 3D model of the site, more of an illustration, but a to scale illustration. And then we use our library of parts to actually produce the drawings from. So you can see a really nice visual representation of what it's all going to look like, as well as engineering drawings that show you dimensions and things that you need to see. Okay. Is there anything you wanted to add to that, Martin, or anything you want me to discuss?
No, I think that was a really good demonstration. The only thing that I'd really like to emphasize on is you can see with these 3D models how we draw the entire asset. And because we draw the whole asset and place the models on it, it means that everyone can, yeah, have some input into the design. We can agree the design between all parties, which means that when we come to deliver the project, it's no surprise to anyone. There's not, because, yeah, if you weren't to do these 3D models, there's always a risk that one party says that's not what I expected, and then it has to be redrawn, and it causes sometimes some frustrations. By doing these kind of models, it means that all stakeholders know exactly what's going to happen, and it always looks pretty much like it does in the 3D drawings, which, yeah, it means that we can deliver it one time only, which is good for everyone. Mm-hmm. Right, shall I take back over the controls then?
Yeah, that's fine. I'll stop sharing now then. I'll leave that to you.
So you should be able to see my screen, James?
Yeah, I can see your screen. Hopefully everyone else can see that as well.
Yeah, if you can, I'm sure they can.
I'm going to go back on mute now.
Okay, thanks for that. And yeah, James, of course, as soon as some questions pop up, don't hesitate to stop me. Yeah, I wanted to look at some prefabricated fish passes. Of course, the large Larinier fish passes in general that we see, a lot of them are a lot of concrete, and we all know that concrete is one of the worst materials possible in terms of CO2. Not only that, but it's extremely costly to work with, because everything has to be done on site. It's a huge amount of materials, and site works generally are expensive works. Therefore, if you can fabricate things in a factory and keep the site works to a minimum, you not only save the site works, but as I say, you save huge amounts of concrete. These are two fish passes that we've delivered, which are fully prefabricated Larinier passes. One's at Cookham Weir, which is an Environment Agency asset on the Thames system near London. It sits next to a bunch of radial gates. And on the right is for a private client, Trafalgar Fisheries, which is a fish farm for rainbow trout. So you can see as well the prefabricated pass. You can see that we've also incorporated a slot at the end, which has got bristleboard in it, allowing elvers and smaller species to be able to wriggle their way up. One thing I would like to say about the design is we're very good at doing the mechanical design. We can do all of that, as you've seen with James. We are not hydraulic flow experts, so we do need guidance from you or from a fisheries consultant to say where the intake level is, where the outlet level is, what the angle is that you want the fish pass to be, how many Larinier passes wide. And when we have that kind of information, we can certainly do the mechanical part of the design, as you can see here. It also leads us to be able to do some really interesting solutions. This was a very tricky site down in Somerset called Oath Lock, where we'd supplied a large tilting weir. So that's a gate which rotates upwards, where we had to put a fish pass, well, which you can see to the left of it, behind that penstock. It's just poking out here in the bottom with the eel pass substrate going up here. You can see the Larinier fish pass in the dry, the penstock upstream shut, and the eel pass that's going in down the side. But the issue here is a Larinier fish pass is inherently designed for fairly static water levels. It can't move too much upstream or downstream. Otherwise, the pass, it doesn't work from a hydraulic point of view. They can work generally between 10 and 15 degrees. So theoretically, we knew we could put some movement in the fish pass. And then when we looked at Oath Lock, the tilting weir really operates on a kind of summer and winter level. So it tends to pen the water, so raise up during summer to make sure the farmers have got enough water upstream for irrigation purposes and such. And then at winter, they tend to lower the door, as you can see in this position, to make sure you've got the maximum possible flood storage capacity available. So we could therefore make sure that this whole Larinier pass can move up and down, which I can show in this 3D drawing here by attaching it to a weir penstock. So that's an overshot penstock. So the actuator here, and it's all connected so that as the tilting weir moves up, so does the whole fish pass. We've got some wheels at the bottom, some rollers, so you can see how the whole mechanism, how it slides upwards and downwards. So that's a really interesting concept which could work on sites where you've got water bodies where the level fluctuates quite a bit. Another way of approaching that is with our fish siphon ladder. So fish siphon works as any siphon does, that you siphon water from upstream to downstream. What we do inside the fish siphon is install a series of baffles to create what is in effect a pool and weir type fish pass within a pipe. So as soon as the siphon is installed, there's a vacuum pump which draws air out of the siphon and therefore pulls the water into the siphon. The air means that we've got an adjustability. We can regulate the flow that's actually passing through. So we basically draw the air out until the first baffle starts to have water flowing over the top of it, and therefore eventually you've got a nice full pool and weir type fish pass. This is an ideal solution where you've got flood banks and you don't want to take big notches out of them for penstocks and things like that to act as a flood defense, because you can literally siphon up and over a flood barrier. These are some examples from the Netherlands. On the left, you can see one that goes around a pumping station. This particular siphon is been doubly effective because this particular pumping station, they had a huge problem with fish kill. They're not fish-friendly pumps. A lot of fish seek shelter, and you can see in the Dutch polders, very flat landscape. There's nowhere for fish to shelter or to hide from birds and things like that. So the fish tend to shelter in the pump sump. Of course, what that means is that as soon as the pumps start up, the fish tend to go through the pumps and the fish kill is pretty bad. Since building the siphons, amazingly, whether it's just the noise of the pumps or whatever, but the fish seem to seek shelter within the siphon. So they're not being cut up, or, well, the fish mortality is dropped off dramatically, the amount of fish being damaged, and they seem to, pretty much migrate up and down through the siphon and seek shelter there as well. On the right, you can see a siphon that goes around a set of lock gates, and you can see the windows that we can put in the top of it. In the UK, we could do windows all the way through, because in the UK, we've got species such as salmon, which there's quite a bit of evidence to show they like to have light, while in the Netherlands you're talking eel, perch, things which are quite happy to sit in shelter. But the windows act as a double purpose. These ones have actually got little windscreen wipers on the inside to keep the condensation off, and it's so that once again schools can bring kids down there and they can peer into it, they can learn about what the siphon's doing, and it's being used as an educational tool as well. Does the siphon work? Well, this is, we've got a bunch of studies, so if anybody wants to see any more, there's only one that I've got really for every product in here. But if you do want more monitoring, just ask and I'll be able to send it over. But this was a report written by Acadis in the Netherlands where they studied 24 different fish passes, everything from shallow V notches to divot fish passes, a whole bunch of different options. And you can see the one that stands out with a country mile passing more than 12,000 fish is a fish siphon. All the other options, not any one of them really got much, that close to a 2,000. So the fish siphon really, really works. In the UK, we have a fish siphon on the River Wissey. So what the River Wissey, the situation that we've got there is on the left-hand side, you can see a canal system which is linked to the River Wissey. So the River Wissey comes up here and over this aqueduct. This is all natural. It's an extremely nice river, chalk stream. It could be great habitat for trout, for example. And the Environment Agency wanted to link the two watercourses up for fish passes. The reason for this is the lock gates at the end of the cut-off channel we're seeing an intake of particularly sea trout. And of course, a canal is not an ideal habitat for sea trout to sit in. So any kind of escape or method that we could get the fish into a good habitat, such as the Wissy, was one that everyone wanted to look at. The big problem is between these two watercourses, of course, this is a flood bank of the River Wissy. So you can't really just take a notch out of a flood bank to build a Larinier type fish pass. Also, the construction of a Larinier type fish pass was going to be very expensive. A lot of the head difference is, I think, about 2 meters. So yeah, large concrete structure, huge amount of civil works. And therefore the siphon was also looking economically attractive. You can see the 2 sluice gates that are here, the left and the right. They are used for flood storage. So as soon as the Wissy looks like it's bursting its banks, they can open this sluice and allow water to feed off into the canal system. But the levels are very different. We placed the siphon in this sort of L shape here that's shown by the yellow line. And you can see the siphon being lowered into position here. Now, we knew that there was a sea trout presence, and that's why the siphon's big. So it depends on your species to the size of the siphon, and also it depends on the species, the distance between the baffle. So we have made siphons as small as 800 mil diameter with a baffle spacing of 1 meter, but this is a 1.6 meters diameter with a baffle spacing of 1.6 to create pools which are significantly large enough for sea trout. On the bottom right, you can see as well bristle board that we put inside it. That serves 2 purposes. One is, of course, the elver migration, but the second purpose is to provide shelter for smaller species, because otherwise, yeah, it runs the risk of becoming basically a food ladder for pike. And that has happened in the Netherlands, where a pike basically lived inside a fish siphon, which wasn't ideal. So yeah, that's a solution to that problem. And then the question of, does it work? Well, we're still waiting for a formal monitoring report from the Environment Agency. They have been doing pit tests and various other things. However, this top sea trout was taken, the photo of that was taken, yeah, literally weeks after the siphon was installed and operating at first. Had a big fyke net on the outlet of the siphon, or the inlet in terms of water. And our customer there from the Environment Agency was fishing on the riverbank and saw this fyke net absolutely flapping about. So he went to go and retrieve it, and that's what he saw. So it's really, really good to see that we got, yeah, the target species from us as ACE. We wanted to see salmonids use it because there are no salmonids in Holland to prove it. But the Environment Agency wanted all sorts, and there have been 1 or 2 eel, perch, some roach, and various other things. But it'd be great to see the data if it's completed. We also, as I said earlier on in the presentation, we really believe in innovation, and we like to work with our customers and various stakeholders to create really clever solutions to fisheries type problems. I'll just stop because I did see there's a question there. Is there a question, James?
Hi, Martin. I don't believe there's any new questions.
Oh, no, it was just a response. Okay. Yeah, so Loch Duntelcheag is in Scotland. It's near Inverness, so yeah, right up there in the Highlands. Beautiful area. And what the situation that they have there is there are 2 lochs next to each other. Loch Duntelcheag, which is this one, and Loch Aishie. The 2 are linked together. So Loch Aishie, up here, the top green circle, that is a drinking water plant. So they abstract from Loch Aishie and produce crystal clear drinking water. When Loch Aishie, and that's supplying pretty much the whole population of Inverness. When Loch Aishie starts to run dry, I wouldn't say it runs dry, but when the levels start to drop off, they then start to send water from Loch Duntelcheag to Loch Aishie to be converted to drinking water. So both of these lochs are critical to Inverness's drinking water supply. They also have facilities to pump out of Loch Ness, but then they have to pump, which of course is against Scottish Water's carbon targets and against what they're trying to do from an efficiency perspective. You can see on the right, which is where the asset is, which is causing a blockage to migration. So that asset looks like this, and it's essentially a weir. So the reason that they need the weir is they need to keep the depth in Loch Duntulchaig for abstraction, of course. They can't just lose all the water because then there'd be nothing for the drinking water. So originally they built the fish pass on the left of it, which you can see has got concrete V-notches in it, which are tiered up towards the weir crest. The problem is sometimes the water's overflowing that weir by a couple of 100 mil, and sometimes during the height of summer, water can be almost half a meter below the weir. So you've got a huge deviation between your top water level and your bottom water level that you need to still allow passage for. There's a double problem on this one, in that Scottish Water also have a hands-off flow, which they need to maintain for the river downstream. So they have an agreement in place with SEPA, which obviously tells them how much water they're allowed, or they must constantly be sending downstream to keep the rest of the river in a good state. You can see the concrete weirs here, and you can immediately see the problem. The one on the right-hand side, you can see there's virtually no water going over the top of it. This was taken in summer. So you can see it'd be very difficult for migratory fish to be able to pass up there. ACE therefore worked together with a fisheries consultant and Scottish Water and George Leslie, the contractor on this particular project, to develop a really clever solution. You can see here we put a series of tilting weirs in a row, and what happens at the maximum level, as soon as the level in the loch starts to drop down, the tilting weir moves with it. So the water is always sat against the crest. If you look at my mouse on this top point of the tilting weir, it's always level with that. So as the level in the loch comes down, so does the tilting weir. Tilting weir drops until it's level with the crest of the second tilting weir. Then the first tilting weir drops all the way shut, and the second tilting weir takes over that control, and and so on and so on. So eventually the third one, eventually the fourth. You can see we put an adherent nape, so a rounded edge to the V-notch, and the V-notch means that you've got a calculable flow area, which means that we can prove the flow that's going downstream, which is what Scottish Water needed to show that they're fulfilling their hands-off flows, as well as allowing fish to pass, and the adherent nape to make sure the water's rolling over to make it as smooth as possible for the passage of fish. So you can see here, the images of two of the tilting weirs out of the four. This is the big one, kind of looking down. But we had a different challenge in the fact that this is a very remote site. Installing any kind of power here was going to cost upwards of £70,000. And that's just to put the cable in. Then you've still got actuators, a control system, everything else. So ACE, once again, with a very innovative solution, we work with a company called Greenbox, which is basically a portable solar-powered telemetry actuator. So these are completely solar-powered, and they have telemetry, so they're connected with 3G to the internet, so they can be steered by a porthole, fully automated, and they're operating the tilting weirs up and down and keeping the fish and the water moving perfectly. That's been installed since 2013, and the solar has never been an issue. There's always been enough power. It's always been working as expected. So it also shows how good the solar is, because in the Highlands, you don't tend to get that much sun, particularly in winter. I wanted to touch on this particular project. It's called Halfweg in the Netherlands. So Halfweg is a large land drainage pumping station which pumps out into the North Sea Canal. The North Sea Canal is the canal that connects Amsterdam to the North Sea. The not fish friendly in any way, and yeah, they were looking at how can we create a fish bypass to at least help get fish into the area before we start looking at addressing the pumps and other things. So as a bypass solution, yeah, it was presented from our partners Fish Flow to use a fish-friendly Archimedean screw. So this is the one that we supply, which is completely encased, and it's got special leading edges to make sure that it's completely fish-friendly. So that pumps water up. Well, I've got a nice video actually, which will help demonstrate it. So you've got the pump, large pumping station in the background here, and you've got the small fish migration pumping station to the right of it. Water gets pumped by the pump, it's raised up, and it's critical that the box or the concrete, precast concrete chamber is higher than the flood defense level because it can fill up as much as the North Sea Canal level. It pumps water through this pipe. It's a large 1 meter diameter pipe, bristle boards lined down one side, but critically at a speed of 0.1 meters per second. That's a speed where elvers can swim against. So it's pumping fresh water into the saline North Sea Canal. The elvers can taste this. It draws them towards where the water's coming from. They swim all the way through the pipe until they enter this box here. Now we've got a small penstock on the outside, so we're letting some flow out of there, which is the exit for the elvers to get into the freshwater system upstream. I could show you the video going backwards, but I can imagine you can all work out it's exactly the same. It's just it allows fish to swim into the pump, through the pipe, and out to sea. So it's the other way around. You can see here the construction. So this is what I mean by the precast cot box. The opening day where everyone was looking at it, but even more interestingly, the monitoring. It was monitored for 3 nights a week for a period of, quite a couple of months, I believe it was. And you can see here on the entrance just how much those elvers are attracted to that fresh water. This is on the seaward side of the structure. And in terms of numbers, in 2013, 130,000 fish, and that's a combination of eel, elver and stickleback. And in 2040, 50,000 elvers alone were caught in 1 week. They also caught bycatchers such as perch, and I think they got some other things as well. But the main numbers were which were the target species, because they were the species that we needed to get from the North Sea Canal into the freshwater system. Absolutely great numbers, 130,000 fish in 2013. That was, and also on stickleback. It was also quite interesting that the eel and the stickleback don't migrate at the same time. They don't seem to get on with each other very well. The same solution can be done with our fish-friendly axial flow pumps. So here you can see there's a fish-friendly axial flow pump, and we're doing exactly the same thing. It's pumping water from the Aselmere up through the pipe, through the dam to the outside. You need to have a non-return, penstock on this side to prevent the deep water coming in, but you're sending out that fresh water to attract the fish out of the saline water, which causes them to swim up the pipe and the other way. This one's also been monitored, and here as well, you can see, also numbers well beyond 50,000 a day on these particular dates. But all the way through, really, really strong migration numbers. So it works. Now, I just noticed we might have another question. Is that right, James?
Yeah, we've got one question come in. It's regarding the Loch Duntal Check project. Was the success of migratory fish passage proven after the project, Martin?
Unfortunately not. They're fairly confident it's working. At one point they were looking at installing a vacuum fish counter, which I'll talk about in a minute. But unfortunately no monitorings happen as yet. We are dead keen to have a vacuum fish counter on there, because it's, of course it's always nice to prove these things. So quickly back to fish deterrent systems. So of course, not all assets can be protected or bypassed only. If there's old existing pumps which are causing damage to fish, you might want to explore the option of fish deterrent systems. Yeah, this shows what they typically look like. They're a stroboscopic light system that we tend to believe in, and that's because stroboscopic light has proven to work a lot more than sound on particular target species such as eel, where there has been tests on eel up to 180 decibels, and it didn't seem to show that much of a response. So with the light system, what it looks like is this. So you can see the sorry, slight technical glitch. You see this particular system had strobe lights, which was stopping the fish from being able to enter a pumping station, which was inflating one of those large collapsible barriers. So the strobe lights, keep the fish out of the front, stop them getting pumped in. They do seem to work because the insides, well, it doesn't smell as much as it did with fish perishing before. And this could be a really viable option particularly for intakes which are the only direction the fish can go. Of course, intakes which are perpendicular to a watercourse, you may be able to use fine screening options, for example, because the water is flowing past, but where there's debris at the end of the line, the fish deterrent systems are definitely a viable option. This was one at Welsh's Dam. You can see just how brightly it lights up all of the water, which can definitely keep all the fish out. That particular image was at Emoda, and we've got a full test report should anyone wish to see it. And we also have complementary sound equipment. So these are sound speakers which have been tested under great pressures to prove that they're working at quite significant depths. We also include UV light on the front of them, and that's not so much to act as the fish deterrent, but to keep algae from building up on the screen. The main difference between what we can offer and alternative acoustic speakers is that ours are completely encased. So the membrane is not pushing directly on the water, and therefore it protects the speaker membrane itself. And therefore you end up with an extremely robust product. I would like to finish up by looking at our VACI system. So this is monitoring. So of course it's all great, and as we got asked from the Loch Dundalchaig, yeah, we'd love to see monitoring reports everywhere. Unfortunately, as ACE, we can't monitor our own equipment because it won't be seen as an independent report. But one thing that we can do is supply you with the absolute best monitoring equipment available. And in our opinion, that's a VACI. And the reason is it counts the fish. It gives you a length of the fish in terms of the silhouette. So you've got a good idea of the sizing. If you then take the camera option, it means you can film the fish